Okay, ladies and gentlemen, hopefully you guys can hear me well. Today, in today's video lesson, we're gonna talk about cofunctions, okay? So, in your trigonometry textbooks, I am on page, I believe this is page 20, excuse me for a minute, guys, while I get myself acclimated and find the page. This is page 30. So I believe I am on page 30 of your textbooks, and we're going to talk about cofunctions. So when we talk about cofunctions, basically the cofunctions are, for example, you know how we have sine, cosine, and tangent. So the cofunctions can be defined, I guess, um, as excuse me for a minute. Here I go. Cofunctions is, for example, it says, notice that in cosine, cosecant, cotangent, and cotangent functions, these cofunctions are based on the relationships of complementary angle. It says, let us look at the right triangle with labeled sides. So let me explain this real quick, and then we'll go into the identities. But just in a nutshell, so you guys have an idea, if I draw a right triangle, always remember that this has to do with right triangles. So if I draw a right triangle, and you guys are going to use your imaginations and imagine that these lines are as straight as possible, you have alpha, we'll call this outside ABC, B, and C. And we'll call this angle right here alpha beta. This would be alpha. It's kind of like that fish looking A. This one right here would be beta. And basically, we know that the sine of beta, if you look at the sine of beta, which is right here, it's opposite over hypotenuse, right? So we know sine is opposite over hypotenuse. So if we want to know the sine of beta, and I'm just going to give you guys a really brief introduction, because more than talking about cofunctions, we're going to talk about cofunction identities, which are a series of formulas. And the sine of beta is B over C, because obviously sine is opposite over hypotenuse. So the farthest side is B and the hypotenuse is C. Now, if I wanted you to find the cosine of alpha, the cosine of alpha is adjacent over hypotenuse. So it'd be the closest side to alpha, which is B, over the hypotenuse, which is C. And they're cofunctions because they complement each other. So what we're going to say, or what we can say, is that the sine of beta equals the cosine of alpha. And when we start talking about special right triangles, we're going to see this expressed a little bit more in detail. But right now, this is what a cofunction is, that they're complementary to each other, right? So what we talk about, or when we talk about the cofunction theorem, it basically says, and let me erase all this, the cofunction theorem, cofunction theorem. And the cofunction theorem basically says, and we saw this a little bit earlier in the chapter, that when you have a right triangle, it says a trigonometric function of an angle is always equal to the cofunction of the complement of the angle. If alpha plus beta equals 90, basically what it's saying is that if I have a triangle, a right triangle, and if alpha, meaning one of the sides, plus beta, which is another one of the angles, to be specific, not the side, the angles, I'm sorry, equals 90 degrees. Of course, remember that all these functions apply to triangles that equal 90 degrees. Equals 90 degrees, then the sine of beta, which we already saw in a minute ago, the sine of beta equals the cosine of alpha, the cosine of alpha, okay, the cosine of alpha, and the secant of beta equals the cosecant of alpha. And these are all trigonometric or cofunction identities, and we're going to go over them in a minute. So basically, the secant of beta equals the cosecant of alpha. So C, S, C. These are all formulas using the complementary principle or the tangent of beta. And the tangent of beta equals the cotangent of alpha. Okay? Equals the cotangent of alpha. See if I can draw that better. Well, imagine that that's a C. Cotangent of alpha. The cotangent of alpha. Now, there are also other trigonometric or cofunction identities, and these cofunction identities are in your book. I'm see if I can draw them or write them down, and then we'll go straight into the example number 1. But cofunction identities. So one cofunction identity is that the sine of z, of z equals, sorry for this, equals the cosine of 90 minus z, the cosine of 90 minus z. Okay, the cosine of 90 minus z. And then the other trigonometric identity that we have, or cofunction identity, is that the tangent of z, so the tangent of z, and again, these are in your book, so in case you guys are having difficulty accessing them, you can go to page, I believe this is page 31 of your book, and the tangent of c is the cotangent of 90 minus z, the cotangent of 90 minus z, of 90 minus z. Now, why 90? Because remember that all of these functions apply to right triangles, and right triangles have 90-degree angles. So that's why we're using 90 minus z. And the other one is the secant of z, or the secant of z, secant of z equals the cosecant of 90 minus z. The cosecant, this is C, S, and C of 90 minus z. 90 minus z. Let me see if I can fix this. This is supposed to say cos, C-O-S. Let's see if I can fix that. So this is supposed to say cosine. And this is supposed to be an S. Better than before. Okay, so we have 3 more, and we're going to do that real quick, and then we're going to go into the example. The other one that we have is the cosine of Z. So we say the cosine of Z, the cosine of Z equals 90 minus, equals the sine of 90 minus Z. So remember, they're complementary. So it's kind of like a ratio. I can, if there's ratios are the same, it doesn't matter in what order I say them, right? Sine is equal to cosine or cosine is equal to sine. It doesn't matter. Of 90 minus Z. And again, we're always using 90 when we talk about cofunctions. 90 minus Z. 90 minus Z. And we have the cotangent. And of course, if you're thinking about the cotangent, if the tangent equals the cotangent, then the cotangent will definitely equal the tangent. So we say the cotangent of Z equals the tangent of 90 minus Z. So equals the tangent of 90 minus Z. The tangent the tangent of 90 minus Z. 90 minus Z. And the last one that we have is the secant, or the cosecant, excuse me. So if the cosecant of Z, and if you're wondering, well, that's probably the opposite of the secant, you are correct. So the cosecant of Z equals the secant of 90 minus Z. The secant of 90 minus Z. 90 minus Z. And let's actually go straight into the example. Now, the example that I'm going to do is example number 3. And we have a triangle. Well, we don't really have a triangle. Okay, so it's basically telling us, example number 3 says, write each function or function value in terms of its cofunction. In terms of its cofunction. So we have the A, which is the sine of 30. Sine of 30 degrees. B, which is the tangent of x. And C, which is the cosecant of 40 degrees. Okay? Let me see if I can. C, which is the cosecant, the C, which is the cosecant of 40 degrees. Of 40 degrees, yes. Okay? 40. So we're going to use the cofunctions that we just learned. And this is 30 degrees. Hopefully that'll, and this is 40 degrees. So if we're going to do the cofunction of, or the sine 30 degrees, they want us to write the cofunction. So the cofunction of the sine is the cosine. Okay, so we know if we're being asked to find the sine of z, we know the sine of z is the cosine of 90 minus z. Cosine of 90 minus z. Cosine of 90 minus z. So what we're going to do is just substitute. We're going to substitute. So instead of saying the sine of z, I'm going to say the sine of 30 degrees. And obviously cosine, that stays the same. Cosine. And you're going to subtract. Forgot to write that in parentheses. And you're going to subtract 90 minus 30. So you're going to say 90 minus 30. And 90 minus 30 is going to be 60. So we say the sine of 30 degrees equals the cosine of 60. Equals the cosine of 60. Oh, wow. It looks like a 68. Sorry about that. Of 60. The cosine of 60 degrees. Again, all I did was I changed the sine of 30, the sine of z to the sine of 30, the cosine of 90 minus z to the cosine of 90 minus 30, and I subtracted that, and that means that the sine of 30 degrees, doesn't look like a 30, the sine of 30 degrees equals the cosine of 60 degrees. Now let's look at the second one, okay? So I'm going to erase this real quick as I can. And the second one says find the tangent of x. So I'm going to look at the cofunction identities, which are in the book, or I've illustrated here on the whiteboard. And you're going to say the cotangent of 30, or the tangent of 30, is equal to the cotangent of 90 minus z. So the tangent of 30. So what we're going to do is, here it is. It says the tangent of z equals the cotangent of 90 minus z. So the tangent of z equals the cotangent of 90 minus z. 90 minus z. So the tangent of 90 minus z, I'm going to change that to the tangent of x. Tangent, and this one is really easy. Tangent of x. And the cotangent of 90 minus x. Now, I don't know the value of x. So because I don't know the value of x, then you're asking yourself, so what's the next step? Well, because I don't know the value of x, I just leave it expressed. So I say that the tangent of x equals the cotangent of 90 minus x. Simple as that, ladies and gentlemen. I don't do anything to it because, again, I cannot I don't know the value of x. So which brings us to the last part of this exercise and hence the last part of this video. And we have I'm sorry, let me fix this because I realized I just deleted it. And the last one is saying the cosecant of 45. So the cosecant of 45, of 40, excuse me, not 45, the cosecant of 40. Let me just write it down here. The cosecant of 40, the cosecant of 40. Now the trigonometric or the cofunction identity says that the cosecant equals the secant of 90 minus z. So this is going to be equal to the secant of 90 minus z. So 90 minus z. And I just plug them in. So I say this is the cosecant of 40 equals the secant of 90 minus 40 minus 40, which is going to equal to 50. So we say that the cosecant of 40 equals the secant of 50. The second, however you guys want to say it. The secant of 50. The secant, the cosine of 40 equals the secant of 50. Okay, the cosecant of 40 equals the secant of 50. And that's it for the cofunctions, and that's it for this video lesson, guys. This is really easy. It's really simple, and hopefully this will help you out with the homework assignment that you guys have. So until our next class, guys, stay safe. All right, bye-bye.